Hi, and welcome to Deepwell Archival Services. In today's brief 5-minute instructional video, we're going to look at data protection, and we're going to look at it from the perspective of how does a cloud-based vendor-neutral archive technology solution from Deepwell Archival Services provide data redundancy and data protection. We're going to look at this in the context of the HIPAA security rule, which calls out for business continuance and disaster recovery contingency plans. So let's look at let's look at a typical diagnostic imaging environment. Okay, you've got a modality, in this case an MRI, and we take a picture of John Smith's cervical spine. So typically that diagnostic study information is going to reside on the modality storage for somewhere between two and 8 weeks, somewhere in that range. Okay, but more importantly, from a workflow perspective, that study is typically acquired by the PACS immediately for viewing and diagnostic purposes. So what happens? Where does this information reside? Where does this diagnostic study exist electronically? Well, of course, it's on the modality storage for a short period of time. The PACS acquires that data and stores it on primary storage. Now, in the case, typically you're going to have to replicate all this primary and archive storage, and we'll get into that a little bit later. From an end user imaging organization, from that perspective, from an end user trying to implement a disaster recovery and business continuance scenario, it can be a very difficult task. So suffice to say that the simplified solution, a cloud-based VNA, the Deepwell on-site server, known as the Enterprise Departmental Server, or EDS, acquires that diagnostic study data in real time from the PACS as well. Okay, for a one-time cost for the life of that diagnostic study data. We're going to provide multiple geographic locations. We're going to provide deep archive in multiple geographic locations. We're also going to provide data migration services as a background process in those deep archive storage centers. So we look at this workflow. Image is created, stored on the modality, acquired by the PACS, stored on primary storage, acquired by our Deepwell Enterprise Departmental Server, and immediately the EDS creates multiple copies in multiple geographically segregated storage centers. So where are those physical studies? Well, again, modality storage, PACS primary storage. That's typically a highly available, highly fault-tolerant, high-performance storage array, a SAN or a NAS architecture and implementation. Then, of course, it's in the EDS on site in our image cache, in the Deepwell image cache for 5 years, 7 years, etc. So then, of course, it's in multiple deep archive storage centers where automated data migrations take place. So this is starting to sound, I'm sure, like a very well-protected, well-thought-out solution. We at Deepwell, we believe it. It certainly is. So where's that diagnostic study? Let's just look at it from the perspective of the location of the diagnostic study data and what happens over time on those different storage locations. Well, the modality here, these green X's imply, as we show in the text down here, implies that the study data is available for deletion. So once the EDS, the Deepwell on-site server, acquires the information, we send it to multiple deep archive storage centers. Once we get an acknowledgement that that deep archive process has successfully taken place in these multiple geographically segregated deep archive storage centers, we then send a DICOM storage commitment acknowledged back to the PACS. So we can certainly free it up on the modality storage. After about a year, let's look at if that data hasn't been touched, hasn't been accessed, it's certainly available to be permanently moved from the PACS primary storage to make room for additional new diagnostic study data. Let's say it sits on the EDS for 7 years, has never been touched. We know that we've got 2 permanent copies in 2 separate geographically located storage centers or deep archive centers, so we'll even free it up to be moved permanently to deep archive, again based on least recently used algorithms. In other words, if the study hasn't been touched in the length of time associated with the retention period, we can go ahead and free it up for removal from that particular storage tier. So again, we think we've got a very well thought out model. We move data between different tiers of storage based on least recently used algorithms and last access times. So we're trying to match the tier of storage, the performance and the cost associated with that tier of storage, trying to match that with the required access time. So we hope you enjoyed the video today. We hope it was informative. We think we have a very well thought out data protection infrastructure. We do it the old-fashioned way, multiple copies in multiple locations. Thank you for your interest in Deepwell, and we hope to see you on the next video.